Hello to everybody and welcome to this week's edition of KETIV Virtual Academy. I'm your host, Tyler Hart, and today we will be discussing technical maturity as it relates to design automation. Your expert for the day is Tom Fitzgerald, KETIV's practice lead for design automation and a regular contributor of great value to this free resource, KVA. Just a couple housekeeping items before we get started. As usual, please feel free to send questions via the Q&A. And we will do our best to get those answered either during the session or at the end. And also all of these sessions are recorded and available for distribution on ketiv.com or on our YouTube channel. So definitely check those out and pass them along to colleagues. Without further ado, I'll pass things over to Tom to kick us off. Thanks, Tom.
Thank you, Tyler. Appreciate it. So thank you, everyone, for joining. Today's KVA, we're going to be talking about the technology maturity for design automation. Now, this is something that I've been eager to talk about with good reason. There's a lot of confusion from my perspective, there's a lot of confusion around design automation and being able to be prepared for design automation. So I'm hoping that through this discussion and this presentation, I can shed some light on some of the things that everybody who might be interested in design automation will benefit from. All right, so let's get going here. All right. So everybody might know me. I am Tom Fitzgerald. I am the design automation practice lead here at KETIV, also a solution architect. I've been with KETIV for just over a year and a half in this role as a manager. Previous to that, I was with Autodesk for 10 years as a solution architect, implementation consultant, technical consultant, a number of different roles there at Autodesk. I've been working with 3D design for well over 25 years, many different tools, as well as understanding the workflows and the environments of those that utilize the 3D design tools. I've been within the manufacturing industry for well over 30 years. My background has a lot to do with heavy machinery, material handling equipment, surface mining equipment. So a lot of big mechanical equipment and how to design and engineer those pieces of equipment. I'm also a United States Army veteran, and in my free time, when I'm not doing the work that I do with KETIV, I am a World War II historian. So watch a lot of documentaries, read a lot of books, and arm myself with knowledge, which is always fun for me. So, all right. So today we're going to be talking about the technology maturity for design automation. With that, we also want to discuss a little bit around digital transformation, because this really lends itself to the discussion in terms of how we want to change, how we want to digitize what we do within our engineering environment. And then, of course, what that might look like relative to technology maturity. And then, of course, I want to talk a little bit about the maturity matrix, understanding where you may be within the matrix, so that way you can understand what you've already done, where you want to be, and then, of course, understanding the steps to get you there. And then lastly, we'll do a Q&A at the end. All right. So here at KETIV, we are focused primarily on the digital transformation journey for our customers, being able to leverage all the different systems and technologies necessary for developing a strong foundation within engineering and design. Not just engineering and design, but also sales and sales engineering on the forefront of what we might do within engineering design. And then, of course, manufacturing and fabrication on the back end of what we might do within engineering and design. What this might look like, we have different sales automation tools, CPQ, configurators, those types of things to help sales and sales engineers being able to capture requirement and criteria information from customers in order to provide a quality product, whatever you may be manufacturing and may want to provide to your customers. From there, being able to leverage design and CAD automation tools in order to facilitate engineering and design to rapidly produce the engineering and design information necessary for manufacturing. Between design and engineering and manufacturing, a lot of companies want to do simulation, analysis, testing. being able to leverage 3D designs in ways that you just can't do with 2D design, right? Being able to leverage and use tools like ANSYS for simulation and analysis. And then finally, being able to work within the advanced manufacturing tools and developing those particular workflows. And what does that look like, right? Being able to leverage 3D design information as well as 2D design information in order to do either subtractive manufacturing or additive manufacturing. But you'll see within this particular slide, there's an underlying thread that works its way through all of these different areas, and that has to do with data management, right? If we think about what we do within manufacturing, what we do within sales engineering, design and engineering, and in manufacturing, it's all about data. Either we're creating data, we're manipulating data, we're consuming data, we have to secure data, we have to share data, collaborate. A lot of times this has to do with either manual interaction with particular data, or as we'll see through this conversation, being able to interface with other systems so that way we can create a digital pipeline. We can create that common thread of inputting information in one end and ensuring that that data maintains integrity and security as it works its way through sales engineering, engineering design, and then manufacturing. So this is a real key component to understanding technology maturity, as well as what it looks like for your digital transformation journey. Okay. So I love putting this slide up because when it comes to visually understanding some of the elements that are involved with creating automation specifically, this diagram really kind of lays it out nicely so that way everybody can understand it. Okay. So why do we need to be talking about technology maturity? Let me back that up a little bit. Why do we need to be talking about this? And it's simply because, quite honestly, over the last couple of years, I've been observing and working closely with companies that are, as we know, with our current environment, it's challenging to find qualified individuals to fill particular roles. Some of the companies that we work with closely are in an expansion state right now. They're growing, they have more business. And in order to be able to satisfy more business, they either need to do one of two things. They either need to hire more individuals, throw more bodies at it, if you will, or they need to optimize, become more efficient. And in most cases, they need to automate different processes to supplement that lack in workforce. Okay. Now, that's all great. However, when you rely upon a human being to do something, it's a little bit easier to convey specific information and work with an individual because, maybe even if they're lacking in knowledge, human beings have a tendency to learn, right? So they'll make mistakes, they'll learn how to do it correctly, and then the next time it gets better. It's constantly improving in most instances, right? Automation and technology does not necessarily work that way. It only does what you want it to do, what you prescribe it to do, what you code it to do, right? So in order to be able to satisfy all the different conditions and all the different situations that you may find yourself in when it comes to working with automation and developing automation for different processes, you have to be very, very specific. And not only that, you have to have very intimate knowledge and to be able to articulate that knowledge in order for engineers, developers, and designers to be able to consume that information and understand that in such a way where there's no room for interpretation, right? So understanding a common language, understanding how to articulate specific requirements and criteria, all that is very, very necessary in order to successfully implement any type of automation, be it on the sales engineering side, design and engineering, and in manufacturing as well. So, these are very common principles that span across a number of the different silos that we're going to be looking at here in this conversation. So what does that mean here within the context of this diagram right here? Well, because we're very familiar with using design tools, be it AutoCAD, if you're doing 2D stuff, If you're doing 3D, using Inventor and Fusion 360, perhaps, there's specific things that we need to be aware of, and there's different rules and guidelines we need to adhere to in order to be able to successfully implement these design automation projects. Okay, and what does that really look like? Right, we have a processing engine, and that's typically, in this case, it would be Inventor. That processing engine needs to do something with files, right? So we need to have a file library, if you will. We need to have content that we can consume. 3D components put all together in the context of an assembly creates a 3D configuration. We'll have typically 2D documentation that needs to follow along the 3D information. And so that way we can start annotating and dimensioning and providing context to what the configuration might be. Okay, so we need all this content, 2D plus 3D information, in order for us to leverage our processing engine in order to create whatever types of configuration or automation that we might need. Okay, alongside that, now that we have the files and we have the processing engine, we also need to have logic. What to do in this situation, under this condition, if we select this value over here, what happens over there, right? So we have to be able to understand all the logic necessary to develop the different configurations or the different processes or even the workflow, even if it has nothing to do specifically with manipulating 3D content. What if we just need to go to a system, extract some information to populate some properties, so that way we maintain that digital thread as we go through the process? Even that, we need to have logic to understand, where do we go? How do we grab that information? Do we need to format that information? And then ultimately, where does it need to land? Okay, so logic or rules necessary in order for us to be able to use the processing engine and then consume those models or files or drawings, whatever the case might be. Up on the top here, you're going to see two other things. So and this has to do with being able to connect different systems. Most companies out there have an ERP or an MRP system. They most definitely have some sort of repository where there might be information. There could be Excel spreadsheets, there could be databases, there could be XML files. So we have data that exists somewhere that in most instances, if we're already not consuming it in one fashion or another, either through automation or we're educating and training individuals to go to a system, look for information, and then populate it over in another system, whatever the case might be. We need to be aware and understand what those other systems are and if they can benefit us. Okay, so if they can benefit us, then we definitely want to interface with them as much as we can. Okay, so the dependencies, the things that we need to understand anytime we want to do some sort of automation, really comes down to these 5 bullet points right here. 3D models and drawings. So 3D models, components and assemblies, 2D drawings. We need to understand logic, be it configuration logic or interface logic. We need to have some sort of rules that we're going to be following. Sometimes, in most instances, we have to be able to interface with a user. We have to allow a user to be able to input information, make particular decisions, supply or arm our users with mechanisms to be able to define the conditions that we're going to be working within. Okay, so we have to define or develop a user interface, that means of being able to accept information. In a lot of cases, we need to understand external data sources. Very few companies out there have all the data that they need for their business contained within the 3D information and 2D information that we use with engineering. There's a lot of sales engineering information, there's inventory, there's accounting, there's costing, there's supply chain information that we might need. So all of this is valuable and has absolutely, in most instances, has nothing to do with engineering. But there could be information there that's valuable that we could leverage within design and engineering. Okay, so connecting to external data sources. And then ultimately, what do we do after design and engineering? What needs to use that information downstream? Manufacturing, fabrication, external vendors, whatever the case might be, additional partners. So we need to understand what are those outputs ultimately coming from whatever we're doing within our automation. Okay. So how does this work within the technology maturity matrix? Okay. So this is an evolutionary process that we're trying to evangelize and instill within our customers so that they understand the best way of being able to be successful when it comes to developing automation and when it comes to becoming more optimized and become more efficient. Okay, so let's look at number one here, level number one, where, and this is what we've seen over the last, well, forever in a lot of cases, right? Everything is manual. We rely solely on human beings to be able to do the work that we need to do within engineering and design, right? So we have a lot of paper information and collateral that we need to maintain. It could be digitized, it could be physical, right? It could be a notepad or something like that. Typically, it's 2D CAD, either using AutoCAD or something of the like, where a digital drafting board, if you will, and that's how we convey specific engineering information. A lot of when we're talking about manufacturing and fabrication, there's a lot of manual CNC operations there, where we're taking engineering information, we're trying to understand it and interpret it so that way we can input that information into our manufacturing machines. And then, of course, there's no data management involved. It's basically a repository out on some network drive or a series of network drives. And once again, we rely on human beings to remember where something might be, or, you know, you got that little sticky note underneath your keyboard to let you know where everything might be, right? So very prone to mistakes, very reliant and dependent upon human beings and their capabilities. And in a lot of cases, their availability, right? I've seen a lot of situations where companies aren't as efficient as they need to be because the human beings that need to do something, the persons of responsibility aren't available. Either they have other obligations, they're on vacation, they're out on sick leave, whatever the case might be, right? So although human beings are very important and we want to use automation, we want to use these tools to support what we do, there's definitely areas for improvement. And that's basically what we're saying here with level one. Everything is manual. Now, level two is what we're starting to see more and more with our customers and those companies in which we engage with, right? Where, yeah, okay, for the last 30, 40, 50 years, whatever the case might be, everything has been manual, but we're leveraging more technology, right? We have some automation when it comes to processes. Think of macros that you may have within Excel files, right? You plug in some information here, it calculates and processes that information, and then we get some sort of output, so we don't have to manually do it, right? We're taking that logic information that we have inside of our minds, and we're using technology to make that repeatable, make it consistent, make it standardized, right? So we're starting to dip our toes, if you will, into leveraging those technologies in order to support some of the manual activities. In most cases, you're already using 3D. Maybe you're not using the best way you can, but you're familiar with some of the concepts around 3D. It's replaced a lot of what you have been doing within 2D. You're starting to understand the benefits of visualization, pan, zoom, rotate, being able to do some simple analysis of, say, clash detection or interference. Your product information is managed in multiple locations. You have a system over here, you have a system over there, but you're still dependent upon a human being to interface and interact with those systems in order to consume and information and collaborate that information. Teams are typically disconnected, right? Once again, maybe you need to email to communicate, or you need to text message or something like that, where you don't have a way of easily sharing information. You don't have that common single source of truth, if you will, quite yet. And there's no systems integration. Everything is kind of isolated. And like I said before, you're dependent upon human beings to create those connections. Okay, so that's level two. And a lot of the companies that we're working with are right here at that level 2 area. Some of them are in level 1, but most of them are in the level 2. Level 3 is really what we're trying to strive for with a lot of our customers right now and the companies that we work with. And this is really when it starts getting interesting. However, it also makes it a little bit more challenging because there's a lot more that we need to be aware of, right? So we have automated systems and processes in place. We're definitely using 3D. We've incorporated training. We have professional training. Our staff has a baseline of education and knowledge in order to be able to use the 3D design tools effectively. We're also starting to leverage some of our simulation and analysis tools. Maybe those tools that are available, say, inside of Inventor even. We can do some FEA, we can do some dynamic simulation to understand how mechanisms may work. Maybe we can do some CFD within the context of Inventor, right? We're using visualization for prototyping. In level 1 and level 2, typically you're using these tools to come up with a design, but you're still dependent upon physical prototypes to do your testing. Within the level 3, we're leveraging our 3D design to do our testing. So that way we don't have to create physical prototypes to do our testing and analysis. And going along with visualization, and I've seen this a lot, I'm trying to really work with customers, is in a lot of instances, companies are still utilizing the 2D documentation for design reviews. And what I'm trying to evangelize more and more is don't use the 2D information, use the 3D information. If we think about how, particularly how Inventor and a lot of the 3D design tools work, is most of the work is upfront, developing high level of detail in terms of the 3D models. We're populating properties, we're defining parameters, we're connecting different things together, and we're leveraging some of the out-of-the-box automation functionality of being able to trigger different parameters to turn on and turn off different components or features or something along those lines. But with that, we're also using that data set for our design review, because we know that if the 3D models are accurate, and there's the association between the 3D models and the 2D documentation, that there's a high level of confidence that the 2D drawings are going to be accurate as well. So why focus on the 2D drawings? Focus on the 3D models. Do your design reviews. Make sure you have a high level of detail and the models are accurate. And if you do it correctly and you understand the best methodologies of producing your 2D documentation, once again, high level of confidence that the outputs from your 3D models are going to be spot on. Okay. So project, you have a PDM where you have a product data management tool in place to store and secure your single source of truth. You have real-time visibility changes. So you're using data management for your version control and your revision control. You're using some of the other collaborative tools in order to share information both internally and externally. So that way, as changes are being made, those individuals that need to be informed of those changes know as soon as possible. And then, of course, lastly is typically there's a PLM where maybe it's a cloud-based PLM or if it's an on-prem PLM, but you have a product lifecycle management tool to be able to work not only with design and engineering, but even sales and manufacturing. Okay? So that's level 3. This is where I see the most of our efforts in working closely with our customers is trying to get them to this point right here, okay, to level 3. And level 4 is the optimized scenario where we ultimately would like to be. This is like cutting edge, best in class type of companies. This is what they're doing. They are the bleeding edge and they see the emerging technologies and they're the first ones to say, you know what? We're going to take a chance on this. We're going to take the risk because if we win, we're going to win real big. And because we already gone from level 1 to level 2 to level 3, we have that experience. We have that knowledge base of being able to understand what to avoid. And then, of course, what to embrace to ensure that we're successful. So what does level 4 look like? Well, we're taking into consideration like Industry 4.0 best practices. We're using 3D factory design. We're using visualization. We're leveraging additive manufacturing. We're purchasing or acquiring machinery that can directly consume 3D models. So that way we don't have a translation process involved. We have advanced collaboration systems. We're connecting processes and data so that way we create and then maintain that digital pipeline. We put information in and it doesn't stop that through that pipeline with manual interaction. There's no breaks in the system, if you will. We have geographically dispersed teams. However, because of the tools and the technologies in which they're leveraging, they are effective and they're optimized, and they're not letting the geographical locations inhibit how productive they might be. And then leveraging advanced process and product performance analysis. So really leveraging analysis and simulation and trying to do as much as they possibly can within the 3D environment, the 3D digital world, before, once again, doing anything relative to physical prototyping, physical testing, anything along those lines. And you'll see the graphics at the bottom of each one of these columns, where you can see on the left side, level 1, it looks very chaotic, right? There's a lot of lines, a lot of trying to communicate, and there's a lot of different files. And now level 2, it starts to refine a little bit, and we're starting to draw very distinct connections to enforce and refine workflows. Level 3, even more so, where we have a single source of truth, that wagon wheel kind of look, where the data is at the center, and we have individuals that have access, and we have processes that have access, and we have systems that have access, and they're all connected together. And then, of course, level 4 is really when that gets dialed in. And we're leveraging analytics, we're leveraging simulation, we have the single source of truth, and we know the best way of utilizing it. So that's the technology maturity. So my challenge to you, anybody that might be on this call, is understand, where are you within the technology maturity matrix? Where do you see yourself? And then, of course, if you are in that level 1 and that level 2, please reach out to us, because we're the ones that can assist you. We're the ones that can guide you and support you to get you from level 1 to level 2 to level 3, and hopefully in the not too distant future, all the way up to level 4. And that's where the real money is, in my opinion. All right. So how does all that play together? What does that look like within the 3 silos that I was talking about previously, in terms of sales engineering, engineering and design, and then lastly, manufacturing? Okay. So a lot of companies follow this format. A lot of manufacturing companies follow this format, where you have your sales engineering or sales individuals that might be doing their estimating, right? They're engaging with customers to understand, what is it that they want? What is it that they need? How many do they need? Of what configuration are they? What specification? So they're capturing all this information. Maybe they receive a request for a quote, and they have to then respond to that request for a quote. Maybe they have to build out layout information. So that way, is this bigger than a bread box? Is it smaller than a school bus? What is it? What is it that we're dealing with? So estimation, sales engineers, sales individuals, they're on the forefront, engaging with customers to start understanding this. So what tools can they use in order to facilitate that process, to start inputting information into that digital pipeline? Well, typically they're going to be engaging with an ERP or an MRP system. Maybe they're using a series of Excel spreadsheets to capture information. Maybe they're even using a CPQ, a configure price quote tool, where they can ask questions of the customer and feed that information. Or they can make that CPQ externally available to customers, so customers can self-serve, right? Think about it. How many of you have ever gone onto, say, a car manufacturer's website, Ford, GM, Mercedes, whatever, and you go to their website, and up in the corner, you see that button that says build and price. I want a 4-door sedan, and I want this kind of engine, and I want it this color, and I want that kind of interior. That's all a CPQ is, where you're defining the configuration, You get done with the configuration and now you have a price. This is what all the options are going to cost. And of course, if you want to commit to that, well, then you push a button, you say, I want a quote, and then I'm going to provide my credit card information or my financing information, so that way I can ultimately, purchase that vehicle. That's all basically a CPQ is. It's a means of capturing that preliminary configuration information. But from there, you'll see within that silo, we have the availability of being able to take off information, right? So even though we input a bunch of information into a CPQ, ultimately we want something out. We want a quote out. Or if we're talking about many different manufacturers, take a pump company as an example, right? Even though I know that I need this kind of pump that flows this much volume under this type of pressure, maybe at these particular temperatures, I might want to output specification information or maybe material specification information of what's all involved within that pump, right? So your initial collection of information within that CPQ, you could still pull off information that's going to be valuable, not only for estimation, but even downstream. And that's where these arrows start coming into play in terms of we're inputting some initial information into the digital pipeline. We want to store that information within the system so that way we can go back and consume or leverage that information later on within some other process. CPQ information is in most instances is still very valuable engineering information. So criteria and requirements around what the sales engineers and the sales individuals and estimation individuals might collect is still very valuable for design and engineering. So why not take some sort of automation to go and grab that as necessary and pre-populate or feed our initial criteria to whatever project model data set we might have. It could be, some sort of configurator that's out there. It could be a means of being able to say, for instance, the output from the CPQ is in a JSON format or XML format. Why not go and grab that, consume it within the design automation, parse through it to understand what is valuable and what can we leverage, and then start populating and configuring our 3D models based upon that design. That's by every means available to you as a customer, right? So why not create those connections to be able to do that? We want to store all of our information. We want to secure it. We want to make sure we're controlling access to it. This is your IP. This is what is allowing you to be in business to begin with, is your information. So having a data management solution that spans across all three of these silos to ensure that we're protecting our IP and we have the information available when we need it, with, once again, a high level of confidence that what we're consuming is accurate, right? So we have our CPQ, we have our design automation. The project data set is not only used within design and engineering, but also manufacturing, particularly if you're doing additive and subtractive manufacturing, as well as maybe you're just an assembler, right? You don't actually create any or fabricate any components, but maybe you purchase a whole bunch of components from different vendors, and your responsibility as a company is just to assemble them in different configurations to satisfy the needs of your customers, right? You can still rely upon that 3D data set and ultimately start pulling off some of the information from that 3D data set to start producing your 2D documentation, your specification information, hardware schedules, material takeoffs, approval drawings, BOM generation. All these things are very common within manufacturing. And we can use automation solutions to go and automate those processes. So once again, we don't have to rely upon human beings to do that. We can minimize the amount of mistakes or opportunities for errors that go along with that manual interaction. Similarly, that project data set can satisfy the needs of manufacturing in terms of any marketing data, marketing and advertising data, manufacturing drawings, or pulling off specific information for external vendors. Maybe you don't do the fabrication yourself. Maybe you rely on a partner to do your fabrication. Well, they may need information in a very specific format based upon how they operate. Well, if you can understand what that format might be, we can create automation solutions to pull off information from the project model data set to ensure it's applicable and accurate for the needs of your external vendors, right? So there's a lot of different ways that we can connect these systems. But the point I'm getting at here is there's very common threads and tiers, if you will, within these silos that we need to be aware of in order to support you through your digital transformation and your technology maturity. Okay. So I hope that this all resonated with anybody that might be on the call, and it makes sense in order for you to understand where are you within the technology matrix, what you need to do to get to that next step, and then of course who you can engage with to ensure that you're optimized and efficient while you're going through that particular journey. So in summary, as I pointed out in the other slides, data management is definitely the foundation. You have to have some sort of mechanism, tool, utility, something like Autodesk Vault or Upchain or some other PLM that you can store your information, you can secure it, you can reduce or even remove duplication or redundancy. The key here is to have security, be able to find what you need when you need it, and then lastly, ensuring that when you do find it, it is accurate and it has integrity. Okay? So data management is the key, the foundation. Also, do not devalue training and mentoring. I have seen a lot of companies come to me saying, hey, I don't want to train somebody and get them up to speed and knowledgeable only for them to turn around in a year and go find another job utilizing the training and mentoring that I gave them. That's you're hamstringing your own workforce by doing that. Do not devalue that training. It's imperative that we have a common baseline in terms of knowledge in order for us to ultimately get to some of those higher tiers in terms of the technology maturity matrix. If you're not familiar with inventor best practices, if you're not familiar with how to use the tool, it's basically impossible for anybody to then be able to articulate how you might want to build out your product the best way or design your product the best way. And if you can't articulate it, then it's nearly impossible to develop successful automation in order to support that. Oh, you can create automation, all right. It may not be the best way. You may struggle along the way. You may spend more time. You may spend more money. You may spend more effort, only for you to turn around and come to a company like KETIV to say, well, we gave it a wrap, but we really don't know what we're doing. And that's because of that familiarity. So training and mentoring is also very important. Don't substitute that. Don't substitute training and mentoring with automation. Okay, still very important. And then the third bullet point here is automation is best when supporting existing workflows. If you don't know 3D best practices, if you don't know how to use 3D tools, automation is not going to solve your problem. It might assist, it might help you a little bit, but it's not going to solve your problems. That comes from training, mentoring, education, developing your 3D content, developing your 3D workflows. And then through that exercise, you're going to be able to identify opportunities where automation can support that workflow, right? Oh, I have to do these 4 steps every single time. Well, if it's redundant and it's repeatable and it's predictable, let's automate it. But you don't know those things until you've gone through this exercise, until you've struggled a little bit, if you will. There's no shortcuts here, guys. There's no shortcuts. 4th bullet point, develop your models with automation in mind, okay? If you gave 10 people a seat of inventor and said, okay, build me this product, most likely all 10 of them will produce it slightly different. In some cases, vastly different. But none of them kept automation in mind. And what I mean by that is, what might change? If something does change, what kind of impact will that make? right? And if you understand how things change, because static files, that's easy, guys. Anybody can produce static files. It's the dynamic information that we need to more closely be aware of. How do things change? How is that going to change the part numbering scheme? How is it going to change the material? How is it going to change what condition or what situation we might consume information if something does change? Change is by far the most challenging thing to put your finger on and identify. So focus on that first and foremost. By understanding that change, then you're going to be able to understand the best ways to automate that change. Parameterization, naming convention for properties, parameters, documenting. This is a big thing, right? If you're going to create automation, and particularly if you want to do it on your own, if you're going to create automation, come up with a naming scheme. What does this name mean? This is the format I want. What kind of value goes into it? Is it of a text value? Is it a numerical value? Is it a true false value? Is it an on off? Whatever the case might be. Understand what those are and not only put them in the models, not only incorporate that into your data, but document it. Because there's going to be a point in time that either it needs to be changed, somebody's memory isn't going to be there, or your workforce is going to turn over. You got to have that document. You have that standard, and so that way you have some level of consistency involved. And then lastly is really understand that digital pipeline, connecting the different silos together: estimation, engineering, and then manufacturing. What are their particular needs? What kind of information do they create? And as you progress downstream, how can that information be leveraged? What are the benefits involved? By understanding that, you'll be able to start creating that digital pipeline. And that's, ladies and gentlemen, is really where optimization and efficiency comes from. That way, no longer will engineering be your bottleneck. So I hope that this discussion, if you will, was valuable and helpful. And then, of course, if anybody has any questions, please do not hesitate to reach out to us. You can reach out to us by calling our number or going to support@ketiv.com. Being able to provide any kind of questions you want, and then we will be answering them as promptly as we possibly can. So with that, I'm going to open up for Q&A, see if there's any questions, any comments, any concerns, anything I can do.
Thanks so much, Tom. That was wonderful to listen to. We do have one question right now. How, as an individual in an organization, how do you approach this as an individual in an organization when you're trying to automate design processes? How do you bring that, I think the question is, to other people on the team?
Yeah. So this is a good question because quite honestly, every company is a little bit different, right? The level of detail that's involved in terms of 3D models and 2D documentation, it really depends on, well, dependencies. What does manufacturing need? Evaluating the current state. I have heard so many times, well, we do it this way because we've always done it this way. Well, does that mean that it's the right way of doing it? You know, is it still applicable based upon the technology that you may be using today? So evaluating your current processes and really getting and questioning it and saying, well, why are we doing it this way? What purpose does it serve? What benefit does it serve? Is it even necessary? Just because this is something we've been doing for the last however many years doesn't mean that it needs to be done today. So when it comes to understanding how much level of detail, it's going to take planning. In all of the classes I've ever done, all the stand-ups I've ever done in front of people, the number one thing is always planning. Take the time ahead of time, get the right people in the room, those individuals that have something to say or something to contribute to the conversation, understand what the needs are, formulate a plan, and then start tackling the plan in very digestible chunks. Understand where those dependencies are. Case in point right here. When it comes to understanding digestible chunks. If you don't know how to effectively create 3D models, don't even worry about the drawings yet. Why? because the drawings have a dependency on the models, right? I'm not saying don't do drawings. I'm just saying focus on making sure that you're developing your 3D models correctly, because if you are, and you're including the right kind of information and detail, what comes downstream from there, the 2D documentation, is going to be that much easier. But if you're not paying attention here, because manufacturer needs 2D documentation, it's all about the drawing. It's all about the drawing. You're doing so much work on the drawing side where you could be facilitating that operation by maybe developing your 3D models a little bit more effectively. Okay. So, and there's also different methods that you can use to be able to satisfy what you might need in terms of level of detail. Perfect example. Everybody, this is a very common one. Hardware. I'm going to manufacture this bookcase or not bookcase, but the shelving unit, this racking system. Well, I have all these steel shapes. I have all these components, brackets, whatever the case might be. But then I have thousands and thousands and thousands of fasteners. Do you need to input every nut, bolt, and washer to be fully detailed within the 3D model? Maybe, maybe not. What's the purpose? Why do you need to have that information in there? Is it strictly just so that the BOM reflects correctly? Well, there's other ways of being able to do that without having to produce high level of detail threaded, quarter 20 bolts to satisfy that. If all you needed is a description, well, then use a virtual component where now you have the metadata, but it's a very, very small file and it doesn't impact performance in terms of making changes to your configuration or even opening up in an assembly sometimes. Okay? So it's understanding what are the needs and then evaluating and interrogating those needs to understand, well, what is the best way of accomplishing that? How do you know what the best way is? Education, training, mentoring, and working with a company like KETIV, where we engage with hundreds of companies that ask these same questions in various multitude of situations where we can tell you, well, it didn't work over here for this company, but based upon your situation, based upon your requirements, it may be something we should entertain. All right. Any other questions?
Awesome. Looks like that's all we have for now. Like Tom said, feel free to check us. Actually, hold on. We do have one on YouTube. Certain high-level stakeholders can be resistant to change in automation, maybe because they see the price tags or outsourcing of the technology. What are some tips for proposing and implementing these? Similar to the other question, proposing them to stakeholders and getting them adopted in a situation where maybe they are ready for it.
Oh, that's an easy one. I mean, you can do a simple cost benefit analysis of what does it cost to hire 5 more people? And the way that I typically calculate anything related to ROI in automation scenarios is getting that ROI within 2 years. Okay. It's a very simple calculation. I need 5 engineers. I'm going to pay those 5 engineers $70,000 a year. What am I at? $350,000 a year for 2 years. That's $700,000. Now, if you can come up with an automation solution that can satisfy those 5 people over 2 years, $700,000, and you come in at $500,000, you just saved the company $200,000. No C-suite level person is going to say no to that if you're saving them $200K over 2 years. So it's a simple argument to have, but you have to be armed with the information. You have to know. So being intimate with your process, asking the questions, getting the right people in the room, developing a plan. You have to do all this up front. Once again, there's no shortcuts. You do all that up front. You do your homework, you do your research, and going to upper level management is so much easier. And if you don't know what to do, come to us. We have a whole staff of individuals that deal with these kind of questions all the time. We can guide you, we can help you, we can point you in the right direction. So that way you can feel confident when approaching upper management about how to make your lives a little bit easier. Or even if your focus is just to make the company a little bit more efficient. whatever the case might be. We're here to help in that regard.
Great. And then a quick question regarding the data management aspect. Does Upchain provide the same level of CAD management with PDM, PLM compared to Vault?
I'm going to say if it's implemented correctly, yes. But just like any other system, if you don't do it right, you don't have the right knowledge base, you're not implementing the right features, you could be hamstringing yourself, or you could be it could just not be as efficient and effective as you want it to be. But once again, if you implement correctly and you understand what your requirements and criteria are, by all means, yes.
Great. That's all the questions we have for now, Tom. Like you said, support at KETIV.com is a great place to get more questions answered. Otherwise, we'll be here again next Thursday, so be sure to join us. And thank you so much for your time today, Tom. That was wonderful.
Thank you. Appreciate it. Was really looking forward to get this information out there. So please do not hesitate to reach out. Be more than happy to answer any additional questions.